Welcome to 5-Minute Math. This is Carrie Rhinehart. Today I'm going to look at characteristics of lines. If you're following along in the book, this is from Algebra 1, Unit 3, and I'm looking at Lesson 7. So characteristics of lines is talking about the domain, range, intervals of increase and decrease, x and y intercepts, end behavior, and rate of change. Now I know that sounds like a lot, but I'll go through each one of them. First, let's look at a specific line. Let's say that we have y equals 3x minus 4. Okay, from the previous lessons I talked about how to graph these lines. I'm going to use slope and y-intercept. So my y-intercept is negative 4. So I'm going to graph negative 4 here. And my slope is 3, which I'm going to change to 3 over 1. So that means I need to rise 3 and run 1 to get another point. And then rise 3 more, run 1. Rise 3, run 1, and I'll have my line. I'm going to use my straight edge here. Okay, I'm going to draw my line, make sure to put my arrows on each end. All right, so the first characteristic that we're going to look at is domain, and you're going to see this a lot, okay, because you'll look at characteristics of all types of functions. We're just starting with lines. So domain just says how far to the left and how far to the right will this function go? Okay, it's the x values. For a line, it's going left and it's going right forever. Okay, I know it's going up and down here, but it's also going left. This is going down and left, and it's going to keep going down and left. And it's going up and right, and it's going to keep going. So it goes left and right forever. So we write this with negative infinity to positive infinity. Because it goes left forever, it goes right forever, and you have parentheses. You can also say all real numbers. The next one we look at is range. So domain is the x's, that's left to right. Range is the y's, that's bottom to top. Okay, so how far down to how far up does this thing go? Again, we said it's going to go down and to the left, so down forever, and up and to the right, so up forever. So the range is also negative infinity to positive infinity, or all real numbers. The nice thing about lines is that all of them have the same domain and range. It's negative infinity to positive infinity for both domain and range. All right, then they also want your x-intercept. That's just where is it crossing the x-axis. Well, in this case, it's right here. So that's approximately 1.50. So our x-intercept here would be the ordered pair 1.50. They also are going to want your y-intercept, and that's where is it crossing the y-axis. Well, that is right here, and that's nice because we could see it from the original equation. That's 0, negative 4 for our y-intercept. Okay. They're also going to want intervals of increase and decrease. Okay. Well, with a line, it's either increasing or it's decreasing. It doesn't change, so you either have an interval of increase or you have an interval of decrease. You won't have both for lines. Okay. So you have to figure out which one is it. Do you have an interval of increase or do you have an interval of decrease? And you always look at a line from left to right. And if you're going from left to right, this thing is increasing. It's going up. So you have an interval of increase, but you do not have an interval of decrease. So we're going to write none. And your interval of increase it's increasing the entire time. The line will be increasing forever. So with a line, whichever one it is, if it's increase or decrease, your interval will always be negative infinity to positive infinity with lines because it's increasing or decreasing forever. We've also got end behavior. End behavior just tells us what the arms are doing on each end, and it's written in a certain way. Okay. So our end behavior, let me see. Sorry, I misspelled that there. It's as x approaches negative infinity, it will always be that first. Then y approaches blank. And as x approaches positive infinity, y approaches blank. And we have to fill in these two blanks. So as x approaches negative infinity, that means as you go left. So if we are on the function and we are going left, we're also going down forever. So our y value is going down, which means it's going to negative infinity. And then as x approaches positive infinity, that means we're moving right. We're also going up. So our y value is going up to positive infinity. So that would be your end behavior. One last thing is rate of change. Rate of change, or ROC, you'll see sometimes, is just a fancy word for slope. Okay. So for a line, you can pick two ordered pairs and do the slope formula, or you can just pick 2 points on the graph and count rise over run. Okay, but in this case, since we have the equation, we already know what our slope is. It's 3. Okay, and even if they give you an interval for your rate of change with a line is constant, so your rate of change will be the same no matter what. But if you wanted to count, let's use this point, -4, 0, and this point, 1, -1. If I counted, I rise 3, and I run 1. So 3 over 1 equals 3, and that would be our rate of change. All right, that's it for characteristics of lines, and I hope you guys have a great day.